Session 12, Disk of the Earth Revisited. In this session, we will learn what the disk of the Earth that we drew earlier represents physically, as well as some important definitions and dynamics that will affect our two-dimensional model. You may recall that we chose to go with the version that has a tilted equator and sun at the center, which is the most common way that we understand the Earth's orbit. Here's a little phrase that you can learn, and it will take you quite a ways. The center of the sun, the center of the Earth, and the line that joins them all lie on the same plane. That plane is known as the ecliptic plane. The equator lies on the equatorial plane, and of course the angle between the equatorial plane and the ecliptic plane is 23.44 degrees. The intersection of the ecliptic plane and the surface of the Earth forms a circle known as the ecliptic. Here's the model that we agreed to use. We have the sun at the center, which is the way it really is in real life, and we have the equator, and all of the circles of latitude are tilted. Now, let's add in the ecliptic, and we want to make a few points here. So we've added the ecliptic. We're going to add the Earth's axis, exaggerated, extending out into space, and we are going to add a line which is perpendicular to the ecliptic plane. Then, in order to get to our two-dimensional model, we're going to turn this until that we're looking straight down the line that we added that's perpendicular to the ecliptic plane. So there's two things we want to notice before we leave here. First of all, the terminator has become a straight line. So make a mental note of that. In our model, we're going to be doing the terminator as a straight line, passing through the center of the Earth. So that's what our two-dimensional model is going to look like. Secondly, we're not going to show the daily spin or any circles of latitude, because when we do, it's a bit misleading, because notice how that if we watch New York City, it is going to kind of be rising higher than and closer to and farther away from the actual plane that we are looking at. So we will not, and the circles of latitude are also tilted. So we won't try to show those in two dimensions. But what we will try to show is if we turn this until we're looking straight down that line, then our terminator will be a straight line, and the disk of the Earth that we drew will be the ecliptic. So those are the points that we wanted to make before moving on. So in conclusion from this session, there are a few takeaways. Everything that on our screen in our model lies on the ecliptic plane. The disk of the Earth that we drew is the ecliptic. And the terminator appears to be a straight line. It's actually a circle, but if you remember the book Flatland, a circle viewed edge on appears to be a straight line. So in our model, when we draw the terminator, it's going to pass through the center of the Earth, and we're going to draw it as a straight line. That's the end of Disk of Earth Revisited and a few definitions. And in the next session, we're going to do some terminator math.